This video exercise is a continuation of a previous exercise covering the basics of modeling an antibody. Here the goal is to humanize the antibody, which involves the selection of residues to mutate. The residues can be selected on the basis of homology or structural criteria. Using the antibody we generated in the previous tutorial, let's now go to Tasks, Antibody Modeling, Humanization, Residue Mutation. Then click Analyse Workspace. After a short delay, the heavy chain is displayed in the sequence viewer, annotated with its disulfide bonds and secondary structure assignment. Note that if you want to limit the analysis to part of the antibody, you can select the relevant part in the workspace first and then select Analyze Only selected workspace residues before clicking Analyze Workspace. Now let's click Search Antibody Database for homologs. Here the progress of the search is shown at the bottom of the panel. When it is done, the sequence viewer includes the results of the search. Next, the homologs must be aligned so that the selection of residues can be done on the basis of related residue positions. So then click Align Homologs. Once the homologs are aligned, you may see gaps in the sequences in the sequence viewer. These are added as part of the alignment, but they do not affect the original sequences or the structures. The lower half of the tab contains tools for selecting the regions that are searched for possible mutations and criteria for selecting residues by variability or conservation among the homologs, or by solvent accessibility or contact with other residues. In this exercise, the default regions, i.e. non-CDR, and default selection criteria will be used. So let's just click Apply to Residues tab. Here, the residues that match all the criteria are selected for mutation, and a message is displayed indicating how many residues were selected. Now, over in the Residues tab, scroll through the table to locate the selected residues. For each selected residue, mutations are specified based on the variability in the homologous proteins. The total number of mutations is reported in the lower panel. You can change them by clicking in the table cell and selecting the residues from the menu that is displayed in the cell. However, we won't make any changes here. The mutated structures are refined as part of the mutation job. You can specify the range of the refinement around the mutation and the refinement method, but we'll use the defaults here. We'll deselect Calculate Binding Affinity. Normally this will be used to calculate the binding affinity of the mutant antibodies to the antigen, which must be part of the workspace structure. However, in this exercise, the antigen is absent, so we won't be calculating any binding affinities here. Next, let's click Run. The job can take up to an hour. When it finishes, the residue scanning viewer opens to display the results, and the mutated structures are added to the project. Note that the results viewer lists the mutations in a table with changes in various properties due to the mutation. It also displays a plot of one of these properties as a function of the table row number. So let's choose the change in stability from the graph property option menu. Here we can plot the change in stability with respect to the parent structure. Notice that one of the mutations significantly increases the stability, one significantly decreases the stability, and the rest have small or moderate effects.